Welcome back. Now this will be the last session for probability, where the remaining two problem that I will show you today, and if time permits, then I will open up one new subject. As I said, it will be a very simple subject to start with, because the condition you can understand. I will not go for a very tough subject where explanation is to be needed more. So I will take up a simple subject. So the problem that we will talk about today, that is number 49, the second last one. It says a bag 1 contains 4 white 4 white and 6 black balls, while another bag 2 contains 4 white. I have written an abbreviated form of white, that is W, meant for white, and B for black. Here in the second bag it has 4 white and 3 black balls. One ball is drawn from one of the bags and it is found to be black. Okay. Find the probability that it was drawn from the bag 1. So this kind of problem we have come across earlier also. So there are two bags. So if I say the bag 1, if I see the event E1, or let's say B1, so probability of picking ball from bag 1, I am not considering immediately the variety of ball we are picking. We are just seeing the out of the two bag. If I see the probability of picking one of the bag, so that would be the 1 upon 2, because there are two bags. The same thing will happen to the bag 2. So the probability of picking any of the bag, as it is two numbers in a sample space, that is 1.5. And while picking black ball out of bag 1, B stand for black ball, out of bag 1 will be, there are 6 ball out of total 10. So this is 6 upon 10. Now you can say why it is not being used as a formula for combination, because we are picking only one ball out of the total quantity of the particular ball. So this can also be said as 6C1, because 6 ball are there. If I pick any ball, the chances of getting one ball out of the total of 6 only, because if I consider this out of 10, there are always chances of picking white balls also. So definite condition where black ball only will come when we will pick one ball. This is out of 6, and as because there are 10 balls in the bag, so this is picking one ball out of 10. So there are the total possibilities of picking any ball, means there I will not consider any specific ball. Here the favorable condition is picking the specific ball. So if we see 6C1 is nothing but 6, 10C1 nothing but 10. So that's why I have taken. So to make you understand, I am just coming to the form of combination, because picking any random balls is not following any order. So this comes under combination. So 6 out 1 out of 6 and 10 out of. So this can also be said as, because we are picking one ball, so 6 ball were there and 10 total number of counters. So this will be the probability of picking black ball when picked from bag 1, and the probability of picking black ball out of bag 2 in a similar way, it will be 3 out of 7. Understand? So now your ultimate requirement to find the probability that it was from bag 1. So my requirement is to get when bag 1. So my first incident out of the two consecutive incident, picking first bag, then picking ball. So my condition is once it has declared that you have picked ball bag 1, and then you have to pick you have picked sorry you have picked black ball. You have already picked black ball, and when you have picked black ball you have to see from which bag you have picked. So the bag 1 is the thing has to happen when you have already picked the right one, that is black ball. So the first incident is happened is picking the black ball, and once it is you have the black ball, now you are going to see whether that ball is picked from bag 1. So this is the probability that you have to decide. So this will also follow the Bayes theorem. As per the Bayes theorem, if I array the probability, this is something like that: picking black ball from bag 1 into the probability of picking bag 1 itself, and in the denominator all those possibilities that black ball may come, that will come when this condition of picking black ball from bag 1 and picking bag 1 simultaneously, plus, or that means plus means or picking the same black ball from bag 2, that also the possibility which will give you the result of getting black ball. Because my first priority is to getting black ball, then you have to decide whether it is picked from bag 1. So this has kept in the favorable condition, and the denominator is always the all the possibilities that possible has to be kept. So this is the condition. But as the favorable condition says only the bag 1, so you will keep the bag 1. If it is bag 2 is the favorable condition, then you have to bring this part up. But the total part in the denominator will be the all the possibilities from picking from bag 1 and bag 2. Now if we put the values, that B1 is 6 upon 10, and this is half. Again this will come the same, and the second part for bag 2 it will be 3/7 into half. Now you see, as this product, these factors are always cancelling. In earlier cases also you have seen it, these factors. So later you can improvise yourself, and you need not to consider this probability function where this and this are equal, because this bound to be equal, because this picking of any any such you can say the commodity from where the further event is to be considered, so those the overall events are equal in nature. Because if we see in any condition, if the individual bags are kept, instead of 2 there are 3 bags, then also the factor will come 1/3 for all the cases. So these factors are common. So instead of that we can keep the individual probability of picking a particular event out of the individual you can say the span, or the you can say the you can say the sample space, because individual bag is a sample space for those balls. Okay, so 6 upon 10, and here 6 upon 10 means you can reduce it by to 3/5. This is 3/5, and 3/5 plus 3/7. So 3 you can see common, so that also can be nullified, and this will give you 35. This will give you 35. 3/5 is 1/5, 1/7. Probability of getting back, this is 3/10. Okay, this is 3/7. Probability of picking back block from the total, this is okay. So now probability of picking bag one when black ball is picked is it is the same one. Now this is 65 35 35 upon this will go 35 and there will be 12. Okay, but here probability is coming more than 1. That is not possible actually. So if I am making any mistake anywhere, the probability of picking black ball out of this 6 by n black ball black ball into half of it will be cancelled out. This is coming 35 by 12. Now let me check the calculation once again. This is 6 by 10, that is 3 by 5. This is 3 by 5. This is 3 by 7. Okay, so half of will be cancelled out. Now if I calculate, 3 will be cancelled out, so this will become 1 by 5 upon 1 by 5 plus 1 by 7. Now if I calculate 1 by 5 upon 7 plus 5, and this will go up 5 into 7. 5. So 1 by 5, 5 will be cancelled out. Oh, sorry. This will be 7. Mistaken some calculation. So the answer will be 7 by 12 actually. Okay. Fine. So moving to the next. Now this is your last and the final problem regarding probability. That is 50th number problem, and it says a man known to speak truth 2 out of 3 cases. A dice is tossed and 4 is appeared. Find the probability that it is actually 4. So that means someone is getting the information through that man when dice being tossed, and the answer he is getting 4, but the probability of man telling it true or false having some percentage. So there could be possibilities that whatever he says may be true or false, but actually my favorable answer must be 4 when it is appeared 4. That means actually dice has given a 4 answer and the man is also telling the truth. So this is the condition. So what are the probabilities initially that needed? That the man speaks true or false. Man speaks true when it is actually 4. Appeared is 2/3, and man speak false when actually appeared 4 is 1/3 probability, and the probability of getting 4 is 1 upon 6 time, because 4 is one of the 6th digit, one of the digit out of 6. So because dice is having 6 digit, so 4 is one of them. So probability of not getting 4 also have some percentage or probability, that is 5 upon 6, because if 4 is not appearing, other 5 may appearing. So this is the not happening of 4. Okay. So now and false means 4 appeared false means that could also happen that he is telling 4, has appeared when it is a false case. That also implies that the person is saying false when it has not 4. So that means he is telling complete false. So that means this is you can say the apparent answer when he is telling 4 but it is a false answer. This is equivalent to actual case 4 is not appeared and he is telling false. This is the true case, means 4 is not appeared but even he is telling 4, that means he is telling false, is the percentage 1/3. Understood? So now my case is that probability of 4 has appeared, 4 has means actually 4 has come, that answer he has got means true, and when we cross check it is actually 4. That means this is the case when the person is telling true and actually 4 has appeared. So on the basis of his answer we will cross check whether it is 4 or not. So then I will reach there. No, actually 4 means when we will got some answer from the person through which I am getting answer, that is true or false, and whatever he said, if it is stands true, when I will check whether it is actually the answer given. So that is the 4, actually 4 when is telling true. So this is the case, true, 4 has appeared, he is telling true, and probability of getting 4. And other cases the same thing will appear in the one part of the probability in the denominator plus telling false when it is not 4. So that is the same case. It is what you can say, the companion part of the total probability 2/3, and the other part is false. False means what is the need of telling false, because he has to match the requirement of the person who is getting answer. So he needs 4, and if he tells that 4 false, that means force is not actually there. Okay, so this is probability of not getting 4. Okay, so this is, it is very typical to understand, but if you keep your calm, then definitely the answer will come and it will be a correct answer. Then the probability of true on basis of any answer needed, this is 2/3 into probability of getting that part, which is actually when you toss a dice, this is the actual case, any number can come in 1/6 part of the total, and this is 2/3 into 1/6, and if he tells false, then you have to match the results also. So false means 1/3, and the results means not happening 4 when the answer needed is 4. So this is 5/6. So my answer will be 2, 3, that means 1/9. The same will be there, 1/9 plus 5/18. Now if we multiply with 2 to match up this, 2/18. So that means 18 will be the LCM for both numerator and denominator. So I can adjust accordingly. So 2 plus 5, that is 7. So this will be the answer for this question when the person is telling true and actually that results has appeared is out of the total possible results. So possible results, either man can tell true and false. False is needed when the answer has to be deviated, because the need is getting 4. So either by true he can reach the 4 or by false, and false is also needed when the result is not matching with the actual. So false will tell according to the result. Okay, so that is also probability. Okay, so there would not be any chance when he has to speak false when result is matching with the actual. There is no need of telling false. So this crisscross is not needed for this case. Okay, so that will not come as a part of it. So there are two possibilities for telling true when results appear, telling false when result is not appeared. Okay, so this is your answer. So I will end up here. Not have time to start with new subject. So I will definitely start in the next class.